This is a video on mass. The question states, find the mass of the wire that lies on the piecewise curve shown and has density rho of xy is equal to x plus xy. So let's look at this picture a little bit larger and notice that this curve has three pieces. The first piece, which I call C1, is parabolic and has equation y equals 4 minus x squared. The second piece, which I call C2, lies on the x-axis, and the third piece, which I call C3, lies on the y-axis. So I need to find the parametric equations, or what I'll do is find the vector-valued functions that represent these three curves. For C1, since it's defined as a function y equals 4 minus x squared, I can let x equal t and y equal 4 minus t squared. And then x is going to go from 0 to 2, and since x is equal to t goes from 0 to 2. For the second curve, it lies on the x-axis, so y is equal to 0. And for the x component, I have 2 minus 2t. It's linear, and when t is 0, we should be at 2. And when t is 1, we want to be at 0 for x. So 2 minus 2 times 1 is 0, and t goes from 0 to 1. For C3, it's on the y-axis, so x is 0, and y is 4t, with t going from 0 to 1, because when t is 0, we want to be at 0 for y, and when t is 1, y is 4. So the mass is defined as the line integral of the density ds. So for ds, I need to calculate the magnitude of r prime for each of these r's. So let's start with r1 prime, and that's 1 comma negative 2t. And the magnitude of that is the square root of 1 plus 4t squared. R2 prime is negative 2 comma 0, and its magnitude is just 2. And R3 prime is 0 comma 4, which has magnitude 4. So the mass, recall, is the line integral over the curve of the density times ds. Our curve is split up into three curves, C1, C2, and C3, so I have three line integrals. So let's look at these individually. For C1, we have t going from 0 to 2. X is t, y is 4 minus t squared, so x plus xy is t plus t times 4 minus t squared. And then ds is the square root of 1 plus 4t squared times dt. For C2, t goes from 0 to 1, so I have the integral from 0 to 1, and x is 2 minus 2t, y is 0, so x plus xy is 2 minus 2t plus 2 minus 2t times 0, and then the magnitude of r prime is 2, so I get 2 dt. For the third curve, t again goes from 0 to 1, so the integral goes from 0 to 1. Here x is 0 and y is 4t, so I get 0 plus 0 times 4t. And then r prime in magnitude is 4 times dt. So let's look at these integrals individually. For this first one, this one's a lot of work if I did it by hand. I could do it, but it would involve trig sub and all kinds of other tricks. So instead, I actually used a calculator for this one. And I got that this first integral is about equal to 15.35. The second integral is actually quite easy. The 0 drops out the second term. So we just get 2 minus 2t times 2 dt. And that integral I worked out, actually, and I got 2. For the third integral, that's just 0 times 4, which is 0, and the integral of 0 is 0. So the total mass is 15.35 plus 2 plus 0. So I can conclude that the mass of the wire that lies on the piecewise curve that we have with density function x plus xy is about equal to 17.35. And I'm done with the problem.